Every single app on your phone, whether it's your social feed, your banking app, whatever, it has a hidden blueprint. And this blueprint, we call it a data model. It's not just code. It's the fundamental language that software uses to make sense of the world. And that language, well, it dictates everything the app can do and everything it's going to struggle with. So today, let's decode that language. The philosopher Ludwig Wittgenstein, he just nailed it when he said, "The limits of my language mean the limits of my world." And for a developer, the data model they choose is their language. It literally sets the boundaries of their digital world. It's what makes a problem either really easy to solve or a total nightmare. So here's our game plan. First, we're going to define what a data model actually is. Then we'll dive into the big showdown, relational versus document. After that, we'll explore the wild web-like graph model. We'll also get into how we actually ask these models for data. And finally, we'll see why the future isn't about picking one winner, but learning how to use them all. All right, so let's start at the beginning. What exactly is a data model? Well, I want you to think of any application you use as a series of layers, right? And each layer is designed to hide the complexity of the one below it. The data model is one of the most important, most fundamental of these hidden layers. It all starts with a real-world problem. A developer takes that reality and translates it into application code, objects, data structures. But to actually save that information, they have to pick a general-purpose data model. And that right there, that's our focus. This is the big decision point. Does my data fit best in something like a spreadsheet, or maybe a nested document, or is it more like a web of connections? Everything below this layer, that's just bytes and electrical currents, way down in the weeds. For decades, decades, one model just ruled everything, the relational model. It's the foundation of all the SQL databases you've ever heard of. But then a revolution started to brew, led by these so-called NoSQL databases, and they championed a totally new way of thinking, the document model. Okay, let's take a LinkedIn profile as an example. In the relational world, you don't just save it as one big chunk of info. No, you break it apart. This process is called normalization. The basic user info goes into a users table. All their jobs, they go in a positions table. Their education, yep, another table. And they're all linked together with a simple user ID. So to see a full profile, the database has to run around, grab all those separate pieces, and stitch them back together, using what we call joins. And this creates a classic problem, something developers call an impedance mismatch. It's awkward. See, your application code is thinking about a whole profile object, but the database only understands these scattered rows in a bunch of different tables. That constant, clunky translation back and forth, it can be a huge source of pain and complexity for developers. Which of course leads to the big question, right? If the relational model powered pretty much the entire world for over 30 years, what problem was so massive that we needed a whole new approach? Well, the answer is all about solving that impedance mismatch, at least for certain kinds of applications. And that's where the document model comes in. Its solution is actually pretty simple. Instead of splitting the profile into a million pieces, just keep it all together. The entire profile, with all of its work history and education baked right in, is stored in a single self-contained document, usually in a format you've probably heard of called JSON. The magic word here, the key benefit of this approach, is something called locality. Because all the information you need for a single profile is already stored together in one place, the database can just go grab it in one quick, super efficient trip. No more running around, no more piecing things back together. So here's the fundamental trade-off. The relational model is fantastic for highly interconnected data, things with lots of many-to-many relationships. It forces you to define a really strict blueprint before you can add any data. We call that schema on write. Document models, on the other hand, they shine with self-contained data, offering incredible speed and flexibility because they check the blueprint when you read the data, not when you write it. That's schema on read. It's really a battle of structure first versus flexibility first. But what if your data doesn't really fit into neat tables or even neat documents? What if the most important thing about your data is the connections between everything? For that, we need a totally different way of thinking. We need the graph model. A graph model is beautifully simple. It thinks in just two terms: vertices, which are the things, like people or cities. You can think of them as the dots. And then you have edges, which are the relationships connecting those things, like born in or lives in. The lines. This structure is just so natural for mapping out things like social networks or building recommendation engines. Really, any problem where the connections themselves are the most important part of the story. Okay, so we've got these three different ways to structure our data. But how do we, ask them questions? How do we actually get the information we want back out? Well, this all comes down to the style of the query language we use. You can really break it down into two main styles. With an imperative language, you're giving the computer a step-by-step recipe. You're saying, loop through this, then check that condition, then add it to the list. But with a declarative language, like good old SQL, you just describe the result you want. You say, get me all the users from London. You don't tell it how to do it. And this is a huge advantage because it lets the database's super smart query optimizer figure out the fastest, most efficient way to get you that data. And this, right here, is where using the right language for the right model just pays off like crazy. Let's ask a pretty simple question. Find all the people who were born in the US and now live somewhere in Europe. Okay, now look at that in Cypher, a language that was built from the ground up for graphs. It's clean, it's concise, it almost looks like a little drawing of the pattern we're looking for. Now, look at the same query in SQL. I mean, it's possible, but it takes this 29-line recursive monster to get the same answer. It just shows that having the right tool for the job makes all the difference. So which model wins? Is it relational, document, graph? Well, the reality is, the lines between them are starting to get really blurry. The future isn't about crowning one winner. It's about combining their strengths to get the best of all worlds. This modern approach has an aim: polyglot persistence. Polyglot just means you can speak multiple languages. So instead of trying to force one database to do absolutely everything, you use the best tool for each specific part of the job. You might use a rock-solid relational database for your financial transactions, a super-fast document database for user profiles, and a graph database to power that people you may know feature. So let's just recap our toolkit one last time. Relational models are your go-to for highly structured, interconnected data. Document models are for when you need speed and flexibility with self-contained data. And graph models? They are the masters of complex, messy, many-to-many relationships. And really, this brings us to the most important takeaway of all. The debate is never really about which database technology is the best. The truly powerful question you should be asking is, which data model best represents the actual shape of my problem? Because when you choose the right language to describe your world, you'll find that solving the problems within it becomes a whole lot easier.